All right, guys, today we're talking about the area under a normal curve. And this is really why we like our data to be distributed normally. Because if it is, then it fits everything that we're doing today. If it's not normally distributed, then today doesn't do us any good at all. So today works when your data is normally distributed. Otherwise, it's a complete waste of time. Some people will still do it and it'll be incorrect and it won't actually apply to their situation. We're not going to do that. So just to kind of introduce, you've got in your notes, you've got these diagrams with a bunch of percents and lines and all these symbols at the bottom that can get a little bit confusing. So let me walk you through what that diagram is showing you. Then we will look at the diagram. So the other day, we were talking about two basketball players. We were talking about, who were we talking about? We were talking about Cameron Johnson, right? And then we were talking about, I can't even remember who the other player was. But they both had about the same average. The first player's average, his name's going to come to me as soon as I quit trying to think about it. The first player's average, I'm going to put that right here in the middle of my curve because when I have a normal curve, average is in the middle. His average was 15 points. Cameron Johnson's average was a little bit lower. His average was 14. Now notice this is still in the middle because Cameron Johnson's average is in the middle of his chart. And the other player's average is in the middle of his chart, right? So it's going to bug me. Why can't I remember our other player's name? Let's find it. It's under standard deviation. We talked about it. Eric Gordon, that's who we were talking about. So this is Gordon's chart. Now, they both had an average and a standard deviation. They are both distributed normally. The difference is Gordon's standard deviation was 13 points and Johnson's standard deviation was 2. So what that looks like on this chart, every standard deviation, I put another line. So over here to the right, I'm going to put another line and that represents me moving up a standard deviation. So 14 points is in the middle. This represents 16. So I've gone up 1 standard deviation. I'm going to do that again and get 18 points. And then I'm going to do that one more time and get 20 points, okay? I'm also going to go down 3 standard deviations. The first one here goes down, since my standard deviation is 2, it goes down to 12. And then it goes down to 10. And then it goes down to 8. So my average is in the middle. Now, one symbol that we've used for average is X bar. Today, I'm going to use a different symbol. It looks like a U, but it's a fancy U. That's going to represent average because that's what our diagrams use. So I'm going to use the same thing. Now, Eric Gordon, his average is 15. So that's right in the middle. And then I go up 1 standard deviation. So I go up to 28. Another way that I could write that is I started at the average and I went up 1 standard deviation. So I could write average plus standard deviation. That means the same thing as 28, just one of them is the actual number and the other one is the algebra behind it, right? So then I can go up another standard deviation, and that goes up to 41 points. Well, another way that I could say that is the average, but this time I added 2 standard deviations. And then my next one is going to be 54, and that one would be the average plus 3 standard deviation amounts. Now going down, I'm going to go down. This diagram's a little bit funky because when I go down 1 standard deviation, I get 2. So I would write average minus a standard deviation. You are never going to write that but you are going to see this notation throughout the homework and the notes today. That's what you need to recognize. You need to recognize that if my average is 15 and I go up a standard deviation, that's the same thing as this symbol, okay? You just need to make that connection. So if I go down another standard deviation, technically I'm in the negative numbers. This is kind of weird. I'm at negative 11. But in basketball, you can't score negative points, but we're using an example here. So this would be average minus 2 standard deviations, and then this would be negative 24. Oops, I want to put that on the bottom. Negative 24, which is the average minus 3 standard deviations, okay? So each one of these bars represents 1 standard deviation of data. Now, what's cool about these bars, when I have normal distribution, is the diagram that you see down here. Because if my data is normally distributed, so if I add data to this is Cameron Johnson's 12. No, it wasn't. He started at 14. This would be 16 points. This would be 18 points. This would be 20 points. And then I would go down 12, 10, 8. What's cool about normal distributed data is the amount of data is distributed evenly throughout this chart. Now, not evenly to each other, but the section of the chart above the average, that first section, is always going to have 34% of the data. The section to the left of the average, this section right here, is 34% of the data. So when you put those two sections together, you end up with 68%, which is what this chart says. This chart says from here to here is 68%. The chart on the right is showing you the individual amounts. The chart on the left is showing you if you're starting at the middle. So 2 standard deviations, if I go 2 standard deviations to the right and 2 standard deviations to the left, that's this much of the chart. And if my data fits the chart, that is 95% of my data. So that means 95% of the time, Cameron Johnson scores between 10 points and 18 points. 68% of the time, he scores between 12 and 16. 34% of the time, he scores between 14 and 16. So you can use this chart to estimate how much something happens. Because if the data is distributed normally, it fits these percentages. All right? So what we're going to do is we are going to use this to evaluate some areas. So on your notes, you've got this very confusing sentence right here. I'll try to break it down for you. It says a normal distribution, so it fits the curve, has an average of U and a standard deviation. And X value is randomly selected from the distribution. Find the probability. P means probability. In this case, it kind of means percent. Find the percent of data that is, here's my X value it's talking about. It's asking me what percent of the time is X in between U minus 2 standard deviations and the standard deviation. So when I look up at my chart right here, U minus 2 is right here. So it wants to know what is the percentage from here on the graph up until I get to the average on the graph. So it just wants me to add those two sections together. So I would take the 34% of this section and add the 13% that is this section. So all I have to do is 34% plus 13.5%, And that means 47.5% of the time, my value is going to be in between these 2 points on the graph. Now let's do that. I think that's way easier to do with actual numbers. So the state peace officers, these are basically police, right? Police officers take a standard and training test. It's normally distributed, so it fits the curve. It has an average or a mean of 55. So that means that my data right here in the middle is a score of 55. I hope that's not out of 100. It is out of 100. Yikes. The average test score is 55%. I hope our police get better scores than that. There's a standard deviation of 12. So that means every time I go up to the next section of my graph, I'm going up 12. So that makes this 67, that makes this 79, and that makes this little tiny one 91. Going to the left, that makes this 43. I go down 12 more. This is 31. And that makes this little section 19. So the question goes on to say about what percent of people taking the test score between 43 and 67. So when I look at my chart, 43 is right here, 67 is right here. So it's asking me what percent of the graph is in between those two numbers. Well, if I look at my chart up above, I'm looking at these two middle sections, and each of those is 34%. So I add those together. 34 plus 34 gives me 68%. So 68% of the police officers are scoring between a 43 and a 67. I feel like that might worry me a little bit about my police officers. Maybe not. I don't know what a good test score is on this test. Maybe it's a really hard test, like to get into the FBI or something. I don't know. Now, an agency in the state will only, I'm reading this example here. It will only hire applicants with a test score 67 or higher. What percent fit that? Okay, so 67% is, or a score of 67 is right there. And it wants that score or higher. So it wants me to add everything above 67, which is everything to the right of that section. So if I go up to my chart, that is this section. Oh, let's use a different color. It's kind of hard to see. That's this section, and this section added together. So I've got to add 13.5 plus 2.35 plus 0.15, and that's going to give me, let's see, 16%, I think. So 16% of police officers get higher than a 67 on the test, okay? I like these questions when there's actual numbers involved, because then you're not dealing with these symbols at the bottom. I'm not dealing with U minus 3 standard deviations and U plus 2 standard deviations. Like, I'm not dealing with symbols. I'm dealing with actual numbers. But a lot of times the questions ask you using symbols. So, using symbols, what is the probability that X is less than the average? Well, I know the average is right in the middle. Do we really need to add this one up? How much of the data is less than the average? It should be 50%, right? Because the average is right in the middle. Number two, this time X is in the middle of the average and the average plus 2 standard deviations. So my average is right here. 2 standard deviations means I go up 1, 2 to the U plus 2 standard deviations. So I need those two sections. So if I go up to my chart, I need this section and this section added together. So 34 plus 13.5 is 47.5. So I would add those two together. 34 plus 13.5 is 47.5%. Okay. Number 3. This one's already drawn, right? What's the probability that X is in between the average minus a standard deviation and the average? Well, the average is right here in the middle. Minusing a standard deviation just is the one, I just go down 1, right? This is average minus standard. So it just wants this one section. Well, that one's easy. That's 34%. Okay, the next one, what if X is less than the average minus 3? All right, well, the average is here. Minusing 3 standard deviations means I go down 1, 2, 3. That's right here. And it wants all the data below that. So it just wants this little teeny tiny section below minus 3 standard deviations. So when I look at my chart, 3 standard deviations is here. So it just wants this teeny tiny piece of data. Well, that is 0.15%. So I go down to my graph and I say 0.15%. And that's it. Okay, the questions are going to give you values. You are going to use this chart over, and especially this one on the right. You are going to use this on almost every question. There will be questions that, like the police one, where it wants you to make your own chart and then put the numbers at the bottom, which is easy because the average goes in the middle, and then you just add whatever the standard deviation is every time you go to the right and every time you go to the left. If you have any problems on the homework, come and visit with me.